first paper, we have other stuff on the general topic, is with Andreas Diemer, ex-PhD student, now a very promising researcher in the at the University of Stockholm, Richard Perkins, that is my department, and Axel Gros, that is an undergraduate student in my department. So it's a very explorative study. I will try to go, you know, on the general picture more than on the detail. It's very descriptive, and you know, there is no real need to spend time on details. I would like to have feedback on the general idea. So I will give a bit of context, very short background of the literature, because the problem is that it's highly multidisciplinary. So we are still digging into various streams. The idea why we are interested in that, very shortly, data methodology, and then show you some very preliminary descriptive on the technological side and on the geography of technology side. So the context is the fact that the mining of critical raw materials, that includes also the famous conflict minerals, and I will later on define precisely, and their combination, their use in many, you know, electrical, electronic, advanced electronic products that we know provides a very important material infrastructure to this shift between Industry 3.0 and Industry 4.0. However, very little is known on the technological and geographical networks between the advances of technology. In this case, in particular, we had to focus on one, and so we selected ICT, and that part of artificial intelligence technologies that are part of ICT, are a subset of ICT, and the demand, the technological demand of critical and conflict materials. This has a number of important implications for socio-economic, but also, you know, geostrategical consequences in regions, in countries, government, firms, and, you know, these resource-dependent value chains. One example, just to give you the idea of what I'm talking about, you know, the cobalt demand for lithium-ion battery is expected to double in 3-4 years, and you see the import exports, I mean, are involving some of the most troubled countries in the world. This is just a snapshot. Obviously, we could expand far more in this direction. The background literature, okay, that has looked at critical and conflict materials is really interdisciplinary. And by interdisciplinary, I mean not only social sciences, okay, but also natural sciences. So for this work, we had interacted a lot with a group of geologists in the British Geological Survey, because we really needed to understand a bit more. Being, you know, a poor economic geographer really doesn't grasp the complexity of, in fact, we were also using the wrong terminology at some point. So this helped us a lot. So one stream of literature look at social, economic, environmental, political consequences of sourcing these technology-related minerals or materials. Another stream of the literature is characterized as material criticality, looks at the security of the supply, precisely at supply chain disruption in various senses. Very related is also the literature on material flow analysis that basically maps stock and flows of minerals, their production, consumption across time and space. And finally, there is also the huge literature on global production network, global value chains, attach flagships in terms of the controller multinational corporations and their geography. And this obviously has looked at this literature into the extractive sectors and the backward forward linkages that global value chains in this resource intensive industry can or cannot generate. Okay, so this is the background. We are still, you know, consolidating that. Why this work? Our concern is really innovation. So what is an old idea that I had in mind, actually, because somebody, an old, you know, friend at Sprue that is not there any longer. We were talking about it a long time ago. We were thinking, oh, you know, invention of new technologies that are somehow implicated, that rely on this critical materials. So we focus on innovation. We look at patents. Okay, is a patent-based analysis. But this allows us to explore the relationship between technological change and technological demand for some of these elements, natural elements, and also shed light at the same time on the geography of this demand and how this overlaps or not with the geography of the supply of these resources. This is an exploratory study that tries to give a preliminary answer to the following question: to what extent the ICT-based paradigm rely on technologies that are related to these materials? How this intensity of critical and conflict materials change over time in ICT, and what is the organizational, national, subnational geography of in this, you know, inventive activities, or better, the ownership of these inventive activities within the field of ICT, and how this compares with the geography of the supply. So the methodology, these are the main steps, very, very quickly. Okay, we use text mining, okay, natural language processing on USPTO data, using the full descriptive text of all patents granted between 1976 and 2017. Then we try to limit our selection of both what we mean by ICT AI and, on the other hand, conflict and critical materials. And we carry out a very simple analysis of absolute relative frequencies of keywords appearance for each of the very detailed technological classes. Obviously, these frequencies are, as I said, absolute relative, but we believe that the evidence, we have some validation also of this methodology, rough at the moment, but somehow comforting. Evidence shows that these patterns might be an effective way to directly capture this relationship. Obviously, this is a very descriptive paper. We don't claim causality. We are just talking about association. And then we also extend the analysis of to patent citations, because patents in ICT AI obviously relies on other patents that are from other technologies that might be intensive or related to conflict and critical materials, and that is an indirect relationship across technologies. And then we carry out a very simple micro level analysis of patent assignee, and looking at this geolocalization to explore the geography of the technological demand compared to that of supply. So critical and conflict material definition in this paper, we selected the 4 officially defined as conflict minerals, that is the famous 3TG, tin, tungsten, tantalum, and gold. This is what the regulation at the world level defined as conflict minerals. Cobalt is not officially considered conflict minerals, but we selected it for a very similar characteristic to the 3TG, And lithium, same story for some characteristics of also concentration of the supply across the world, and relationship with human rights abuses, exploitation, and of human rights in general. So these are the 6 selected. Then what we did is also to validate this, oops, I don't know why it's jumping. We try to validate this approach of keywords because obviously we have a problem of false positives, right? Because there might be that some patents actually the inventor, you know, report the fact that he or she is looking at a way to substitute these materials, and therefore we investigate to what extent, let's say, global trends in keywords appearance predict global production, okay, of each of these materials between the 70s and 1970 and 2017. So you can see then this is, we ran a regression, and you know this charts gives you the linear fit between, let's say, the logs of production and the keyword occurrence for this period. And you can see that I mean the match is quite good. It's comforting our idea that this method is capturing something that is very, very aligned. I mean, you can see that our measure seems to fit the production data quite well, okay, with the exception maybe of tungsten that is not so aligned. But generally speaking, data on production of each of these material comfort that we are not picking up totally a random phenomenon. For the ICT and ICT related artificial intelligence, we follow the methodology that is there, first starting with the WIPO definition, then using OECD classification, and then identifying AI patents in ICT, following 2 quite well-known approaches in order to focus our analysis to all ICT and distinguishing within ICT that part of ICT that is also AI. So generally speaking, these are just, you know, charts that show you that particularly since the end of the 90s, there is a surge in patenting activity, particularly related to the classes that covers obviously communication information technologies, and this shift towards more and more electronic intensive kind of invention and innovation activities. Now you can see on the other charts that by selecting the top classes, excluding the big section of C, which is metallurgy and obviously is intrinsically more related to the minerals, okay? So we can see that the highest related to these minerals and materials are in fact all classes that are within ICT. So this is just to show you again, I have 100 of this. These are the relative frequency of selected keywords by IPC4 class, so detailed technological class, and you can see by technology, these are supposed to be the top 40s. Obviously, we have also frequency by each of these materials, or absolute, because some can obviously include more than one keyword, so more than one mineral or material. So anyway, you can see that there are, and this, I mean, at the top are all ICT technologies. So what we ask, very simple, I mean, a very simple way to look at if ICT is different from all other technology in the use, in reliance on this specific keyword, we run very, very simple, you know, we examine basically if there is a statistical significant difference between ICT, the blue line, and all the other technology, green. And then we also look at AI technologies that are within ICT separately, okay? So you can see that basically, you know, dividing up, calculating conditional means of relative frequently, dividing, broken down this conditional means in interval of 5 years, also to look at how this relation changed over time, and the 90% interval confidence interval can tell you, you know, in order to compare across groups and within the groups. And what we get is, in fact, that ICT seems to be substantially, significantly different from all the other technologies, and that is not dependent on the subset of AI within ICT, okay? Use keywords more intensely, and they use keywords more intensely over time than any other technology, and particularly this relationship is stronger since the 2000. This is okay. This is another way. This is the citation analysis. This is a chart that refers only, we in the subsequent analysis of citation, we focus on the most recent period, so 2000, 2017. And what here is reported is just that this is backward citation from ICT to other technologies. And what the graph seems to suggest is basically that the subclasses with higher centralities, that are those in blue, actually use critical and conflict material more intensely. And therefore it would seem that ICT technologies, when citing non-ICT patents, prefer technologies that are intensive, according to our definition, in critical and conflict materials. So for the citation analysis, what we do is, I mean, we follow the classical methodology of Hall, Jaffe, and Trettenberg for taking into account the fact that over time, all patents tend obviously to cite more prior art, so more, and so we basically demean citation rates. We wait for the average number of citation by class. So this is really very, very well-known stuff. But what is interesting to see is that this is the marginal effect of at least one keyword frequency on the citation rate. And what we see is that the higher the relative frequency of critical and conflict mineral keyword appearance in a technology, the more likely is this technology to be cited by the aggregate ICT technologies. Now, this relationship grows quite strongly up to 2005, but then tend to diminish to 2015, but remaining positive, okay? While for the other technologies, obviously this relationship is not positive, although you can see that tends to be insignificant, at least, but in more recent times. So geographical is what's the time? I'm losing a bit track of the, okay. The geographical analysis, for the geographical analysis, obviously we want to look, for the moment we have looked at the patent assignee. So we want to, just because we were interested in knowing who owns the technology more than who invents the technologies, that is a subsequent step that we might want to explore later on. And so there is obviously no surprise in seeing that these are the top 25, but in the whole list, we see the big tech. Okay, so the many familiar electronics, and so big tech primarily located in Japan. Japan is the country more present, followed by the US and South Korea. So the usual suspect, okay, Samsung, IBM, Canon, Micron, Sony, even Apple is there actually, and few chemical, pharmaceutical giant. You can see here, I don't, because if I don't have DuPont, for example, Bristol and Myers, and there is also Pfizer. These are the big pharma, pharma that, as we know, are the most, as also I remember from my co-author and mentor John Cantwell, are those that diversify more technologically speaking over very long period of time. So they are active in technologies that are not necessarily related to their production lines. Now, geographical analysis here is by country. We have a problem of significance of data recording in the case of Taiwan and then China. So there is I mean, the series starts to be reliable from late 90s. But what we can see is that from here, South Korea, Japan, and Taiwan are those picking up the most, particularly in the last couple of decades. More interestingly is to look at, to repeat the same exercise we did for the technologies, but by big areas, okay, using the United Nations macro region, Americas, Asia, and Europe. Now, is the same exercise, okay? Conditional means broken by intervals of 5 years over time to capture this relationship. And we can see that, I mean, the three areas started from a comparable level in 1975. And then you can see that the Americas, okay, became even significantly different from the other areas, although interestingly, while Europe was going down, and this obviously reflects somehow also specialization behind, what has grown, particularly since the 2000s, is Asia. And you can, in ICT and AI intersection technologies, and you can see that Asia is, although is not significantly different from the Americas, but is on the trend, let's say, to become so. So then we started to look at the specific geography of all this, right? And these are simple maps, okay? The maps using ArcMap or whatever software, in order to identify the location of the most productive assignees. And so we tried with different thresholds. In the case of US and Europe, a good one was those assignees, so those firms that have more than 100 patents. And in the case of Asia, we had to put more than 500 patents. Here I report these maps, and you can see that it's interesting because the geography of this most productive patent holder that are related to these critical materials are obviously in specific locations where, in fact, there is this preponderance of multinational corporation, big tech, and clusters. Okay, so I mean, it's California, New York State, and Texas. In the case of the US. In Europe, you can see that is mostly north of Europe, then London, a lot Germany, and also the Netherlands, Belgium, but very, very specific clusters. So these firms obviously interest some location in Asia, we see that is obviously Tokyo, the top location, because Tokyo and Osaka, actually, because Osaka also have is one of the hubs, but followed by Taipei, Singapore, and Beijing in China. So then in a subsequent step, we are still working on that. This is very rough. This is firm patenting versus each site is just one big map, so you cannot really see anything because it's difficult to disentangle all the 6 minerals. But basically, the message that we have in more detailed maps is that, you know, as expected, the technology is all global north, and most, not all, but most of the critical and conflict mineral, particularly the conflict actually subset, are in the global south. So this is the first snapshot of the idea. And what we can conclude is that there is evidence, although imperfect, although we are you know, thinking about many possible ways to think about this association between ICT, technological paradigm, and this conflict mineral innovation. First of all, we want to expand in other sets of technologies that are not ICT, but also to refine a bit better this method in order to clean it, for example, by, I mean, there might be patents that are now relying on recycling these materials that can be confused with ours. I mean, we are aware of a series of limitations on this. However, there is this association and also data validation, production data. I forgot to say that the mining sites comes from obviously a different data set that is based on the US Geological Survey, and so there are different data sources to match also in order to validate better this methodology. ICT is significantly different from other technologies in terms of their reference to critical and conflict materials. We see that there are two sort of forms of spatial disparities, or two levels of spatial inequality, if you want. That is the expected one between global south and global north, particularly, and here there is also the attempt now with another co-author to capture better some of these critical or conflict materials, because then there are the rare earths, and you know, so there is scope of increasing the analysis also from the material point of view, understanding better the material, for which as I told you, we need support from colleagues in different fields. And also to explore, for example, in the logic of the value chain, which are those that could in principle generate some kind of more positive spillovers for the local extraction industry, locally owned or miners. And then there is the second level of spatial disparity that sees the concentration of this technological demand in some very few location hotspot of the global north, okay, that are the home of the big tech, and so this connects to another you know, other lines of research that look precisely at the monopoly of the large tech and their disruptive effects on you know, on global north, but also on global south. And so we conclude by saying that, you know, this intuition that specific technologies area paradigm have actually distinctive resource signature, okay, is a relation that is interesting to explore, and that has a lot of important implication in terms of demand of these resources and also geography of these resources. So it's in progress. Thank you very much.
Thank you very much, Simona. So if you want to stop sharing, then we can.
Yeah, exactly. I was trying
on the top, I think.
Yes, yeah, so that I can see the people. Yeah.
So we can also give the floor to people that want to ask questions. So John Goddard was asking. John, do you want to ask the question yourself?
You're mute.
Yes, thank you. Hi there, Simona.
Hi.
Fascinating. You were getting onto my question towards the end, which was about the industrial structure of the supply side and the power structures there, and the companies, and how the supply chain was functioning, and the extent to which it was global north companies that were controlling the supply chain as well. Could you elaborate a bit on that side of your analysis? Thank you.
Yeah, thank you very much. That side is not in our analysis, although we are obviously aware, and this is part also of the future of the research that has to really focus on the value chain. We haven't. We have started by focusing on technology. Okay, it's a huge topic, so it's difficult to but yes. Mining companies and geographical origin of the mining company is very, very important, matters a lot, and particularly matters because in the last decades there has been a surge of Chinese mining companies, in particular the context of Africa, or the triangle, the lithium triangle in Latin America. So that is something that we will try to attach to this research, and actually there is already work done on that. And therefore we will try to connect if anyone is actually has anything on that. We will be very, very interested in. We cannot cover everything in this respect, but it's a very crucial point. Thank you.
Thank you.
Lisa, do you want to ask?
Yes, thank you. Nice to see you, Simona.
Hi, Lisa.
You look really well. Thank you so much. And also, I really enjoy your talk. I have to say, absolutely fascinating. Something that sometimes is forgotten, what happens at the very, very, very beginning of a value chain. And I was just wondering, because I really have no idea, what kind of innovation are done on these in relation to this CCM? Is it about mining? Is it about processing? I just could not visualize what type of innovation would be patented in relation to these minerals. And the other question that I have, if I may, is there any chance that some of these these patents on CCM, can they also be applied to other industries? Like I'm thinking, for example, automotive. I'm thinking about, although autos are becoming more and more digital enabled, but still, did you check, or do you think it's worth checking whether the CCM patents might actually be used in other sectors? Thank you. Very, very interesting presentation. Thank you.
Thank you. Thank you, Lisa. Thank you very much. It's a very wide use, and it's related to precisely batteries. So we are now exploring precisely, with the geology friends. They have a lot of industry, let's say, connections for with the automotive industry, okay, precisely because he's one of the big user. So consider here we are looking at technologies, not at industries, but it's obviously one link to be done, as John was suggesting also, this industry structure story, okay? These are minerals. The cobalt is crucial for miniaturization of electronic components. Okay, so every single mobile laptop has cobalt inside. Okay, so microelectronic circuits. So it is a very wide range. So we had to select ICT technologies, but I mean the use of these technologies at the industry level is wide. Okay, so I'm talking about ICT technologies, not necessarily ICT industries, the user of the technology. So I mean it's a very, very wide use, because miniaturization cannot happen without some of these materials. Okay, and then the more you expand into other of these, I mean, for example, the rare earth, the more you find specific technologies that are specific to some industries. But ICT being, you know, as we know, general purpose, it's used by a huge number of industries. Automotive is one big user. Okay, so this is again something that we will do also, because by as you know better than me, shifting to value chains, you need industries. So it's a bit problematic, because, for example, it would be very interesting to, and we started to look at export imports of this critical material, which in some cases is very distorted. Because, just to give you an example, the cobalt that comes from the Democratic Republic of Congo is actually smuggled through Rwanda. And so there is a whole gray to not call dark area there that, you know, it's difficult, it needs more thinking how to capture. There is work for everybody anyway here, so join in.
Tassos?
Hi, thank you very much. Thank you, Simona. That was very thought-provoking. It's a bit outside my research area, but it's really interesting. I think it would be really, I have three kind of comments, I think. The first would be really interesting to see what size of economic activity depends on these materials. And I mean, now it will be approaching 100%, I think, indirectly, at least for sure. But it would be really interesting to see if there is some sort of indication of what we are talking about, what is enabled by these materials. The second is, I'm not familiar with the data from the USPTO, but my understanding, limited, is that it's the most expensive patent office to register with, and it's also kind of necessary if you're doing business in the US. So you may have some self-selection in the geography between Americas, Asia, and Europe. And what you'll be observing probably is that the European and the Asian are the real tigers of these countries that register there probably. And the final thing is, it will be very interesting to see if you can observe in the data at what level of demand or price or geopolitical reasons we have episodes that create substitute technologies. So technologies that do not use cobalt anymore because cobalt becomes more expensive or is owned by a country that another country doesn't want to work with, etc. But these are all, I think, a bit too simplistic.
No, Tassos, you touch upon a very important point. I mean, size of the activity, as I said, okay, I mean, this is the first step in this research, and so we had to start with something, and we started with technology. USPTO, you are right, we are very well aware of the bias. However, think about something. First of all, USPTO has been the one that gives you more solid data back on time. Okay, so it really covers from the 70s onwards, and therefore to look at the trend is very, very important. It is also true that this kind of technological development is, as our data set shows very clearly, mostly done by big tech, and big tech, wherever they are, they patent in all of these data sets. Now we can at some point replicate, once we are more you know, into the, we can replicate with the, you know, the European Patent Office. But one interesting thing that is emerged by presenting this work has been also to look at the Chinese patent data, because Chinese are very, very big in this. And therefore it might be that a number of smaller player appears. So now I have a Chinese student that is looking into that, because obviously, you know, natural language processing in Chinese is beyond the competencies that the research team has for the moment. So that is important, but you are right. I mean, it's also in the paper, this note on the USPTO that might be slightly biased. And substitute technologies, that is actually what is in the conclusion critically highlighted as one of the final objective of this research, is to look at looking at this level of technology over time, if we can capture something that departs, and therefore that starts substituting technologies that not only technology is substitute, but technology that recycle better. And you know, there is a potential for some kind of prediction based on this. We have to refine a little bit more, and then the method, in order then to be able maybe to pick up something that is a bit more, let's say, positive and cheerful, because here the story at the end of the day is not.
Well, I don't see any more person wanted to ask any question, but I have some comments. As Lisa and others say, I think it was very, very interesting. I think it's a novel way of always to think about something that many other researchers have been looking at the past, you know, with all the pharmaceutical patents history and things like that, in a more kind of novel and actual way. Because I think nowadays big firms are so much concerned about also all the social corporate responsibility. I'm also thinking that the social impact of those value chains, if you want, it's something worth to explore, in particular because you're talking about those countries and where those patents have created value, you know, to whom has benefited. Also thinking about maybe ownership and corporate governance. You were talking about how Chinese companies are exploiting those kind of mineral mines in using sometimes children. So I think that there is a huge scope in thinking about the social implications of all of these value chains. But that on the origin maybe of this mineral side. On the other side, I think that there is also a new literature on the value of patents, and also thinking not only on the quantity, but also different patents generate different value added, and also they have different type of value in where they are used. So I think it's linked with what Lisa was saying. If they are, some of them, they might be more key-enabled technologies, other might be more specific. So therefore, maybe the use of one mineral or another might have different purpose as the final value of that particular patent. Yeah, I think Brown and Hall is doing a lot on the value of patents comparing to the quantity of patents. So there are some papers on that. I think somebody in the chat.
Thank you, Raquel. Thank you very much. These are all very important consideration. In fact, you saw in my very compacted one slide on the literature, there is already huge literature that looks at these minerals and, you know, the link with the corporate social responsibility. Now, I mean, I have my own reservation, let's say, on the tail of corporate social responsibility, okay, because it's been, in the sense, it's been a way also to shift to the private business firm the task of ensuring that everything is okay, and it's been there, you know, also in the last, let's say, 20 years has become very big. But I see other colleagues like Elisa Giuliani working a lot on that. I know very well her work. Actually, this research has been presented for the first time in a workshop organized by me and Elisa on the dark side of the innovation at the GeoInno last year. And I mean, you know, the serious work done on this shows that a lot is actually window dressing. Okay, so I feel, and I mean, I'm not qualified to go into that, but I feel that there is seriously the need to regulate this in a solid way. I know that a lot of work is being carried out at the European Commission level on this, for example. And in the United States of America, regulatory bodies, there are connections between these two areas in this respect. And I see things moving more on that than telling firms be good. Also because think about some of these critical areas. Now, the Democratic Republic of Congo is estimated, although this again is, you check different sources and you see different estimates, but to produce between 35 and 60% of the cobalt in the world. Now, talking about corporate social responsibility in firms that are located there, right? I mean, just 2 days ago, the Italian ambassador was killed in there, okay, under the eye of everybody. So I'm not sure that is the way to go. Something can be done to strengthen that in certain contexts, but I am a bit skeptical on the real solution leaning on the corporate social responsibility. The value of patent, that is an excellent suggestion. Because I believe that it's very relevant in this. So Browning Hall, I will check that. It's a very, very good suggestion. And I saw also that John was mentioning Sustainable Development Goal. We are in fact trying to align with that literature too. I have another PhD student who is actually focusing on SDG, particularly relative to Africa, focusing to link this topic with SDG because it's obviously very, very important. But as I said, I mean, what was a bit the, you know, the spirit is, this is a big topic. Now, we're not going to go into all the directions because we don't have the competencies to do that, okay? There is all the other side of the story is in the exploitation of these minerals by local populations, okay? Yes. And that could be really a very important source of local economic development. And, you know, there you need also other tools, other methodologies, and so it's really very open. And yes. It's just, I wanted to flag, if anyone thinks about doing this, please let me know, because we need.
No, there is in Groningen there is Frank van Klee. I don't know if you know him. He does a lot on social impact assessment. He has also every year winter and summer schools on social impact assessment with practitioners, and So, and they do a lot of work on Africa, different type of plantations and exploitation. So I think this is probably one of the friends I can recommend you to go. I can introduce you to him and the wife that also has a company on social impact assessment. Yeah, so yeah, fascinating. I think that we are right on time. I think so. If there is no more questions,
can I ask a question?
Yeah, absolutely. Yes. Please go.
Thank you so much for Simona's talk. I noticed you have the geographical analysis and also you have the temporal analysis about the change over time. I just wondered whether you have considered it would be any clustering pattern if you look at by the country boundary in terms of the way the patent emergence across the time, because I would imagine, even though you mentioned they are clustered in Amsterdam and also some major cities in major countries, but I mean the emergence of this patent, are they actually occurred, have any pattern based on one country, or they randomly appearance in different places, mainly because of a company? I wonder whether that's one aspect that you have looked into. And on the other hand, you mentioned you would be interested in explore the patent in China. I thought I can offer you a thought about my experience with Chinese patent. So basically, the patent system in China, they were designed in a different way as an incentive as UK system and US system. I remember like researcher told me, well, they have to pay themselves to get patent, and also as a way of being examined by the government and university as a way to get promoted. So I guess from that perspective, patent has not only been as economic incentive for a researcher, but also they have their own willingness to patent it. So I would imagine that would have an impact that could possibly lead to certain, I wouldn't know how to explain that, but I would think they are patent for a different reason. I mean, just a thought on that. Thank you.
No, thank you very, very much, Celia. What you say about the location, obviously, I mean, we start with the big firms, or we start with the big the big players, okay, because what we didn't know, but I mean, really the big majority is very, very important. That is all very concentrated at the organizational level. And it's interesting because, as you know, patents do not register only firms, okay? There can be other organizations. And actually, the only non-private owner, non-business owner, big, is the Board of University of California, that appears in the top 500, okay? Interestingly enough, so I mean, you know, we will go to, now I showed you the maps with the threshold, because otherwise also in order to present the map, you don't see anything. So it's also a choice a bit dictated by visualization. But we have to go much further with the geographical analysis. This was really a preliminary story. The Chinese patents, I know the very big difference. So using Chinese patents won't obviously allow any comparison with other patent sources, okay? While Tassos was saying EPO data can give you a bit different picture, and they can be roughly compared to USPTO, capturing Chinese data and is not in that direction. I know here that we have a big problem of quality, in fact. However, it's interesting because guess what? Looking at this preliminary, the big patent owner in this in these critical and materials are not business firms, are universities in the case of China. So interesting, yeah, to see. Yeah, you will see at some point. I mean, we can also get in contact for this.
I would love to follow up. Thank you so much. I also remember you used to write about the structural agglomeration. Do you think you might go into it and explore the different kind of different type of agglomeration type driven by transaction code, or that kind of structure, to examine a little bit about it?
There are different directions, right? I mean, it's a big job, so we'll I have to find also some money for it, because you know, is rather labor intensive. Let's put it this way. So.
Well, thank you very much, Simona. I think everybody enjoyed very much your presentation, so it looks very, very, very promising. So I think we are, all of us, we are thinking in what is coming next. So keep working on that.
Thank you so much, Raquel. Thank you all for a very, very nice exchange. And as said, if any of you is doing something related, because it's part of a big puzzle, and it would be really nice to share. Thank you really very much. It was a pleasure.
And thank you very much all for joining us today. In 2 weeks' time, we will have Kevin Morgan also giving a seminar. So we look forward for the next seminar as well. Have a nice day, and see you soon. Bye.
Bye-bye. Bye-bye. Thank you all.